Let us identify the region that satisfies the inequality of which the boundary line is y is equal to x. The boundary line is this line, y is equal to x, is written x is equal to y on this occasion, but there is no discrepancy. The inequality is x is greater than y. We therefore need to identify the region which satisfies this inequality, which is the region for which the values of x are greater than the values of y for every single point in that region. For every point in this region, the value of x is greater than the value of y. Now, we identify the region to be this region, which is below the line y is equal to x. As a matter of fact, it is not touching the line y is equal to x because this inequality did not say greater than or equal to. Therefore, the values of y cannot be equal to the values of x or vice versa. Since the values of x and y cannot be equal, then the region that we shade cannot or should not touch the associated line. Now, it might be a discrepancy because we have x is greater than y, yet still is below. Therefore, what we can do is make use of test points that will verify that the region is actually correct. This is the region and should not touch the line since the values of x and y cannot be equal. We said that already. Let us use test points to verify that the value of x is always greater than the value of y in this region. As a matter of fact, for every single point in this region, we will use test points to show that the value of x is always greater than the value of y. And there we had the first one. Let us take a look at it again. That point is 80, 40. And take note that the value of x is greater than the value of y. Here comes the other one. The value of x is 120 and the value of y is 100. Value of x is also greater than the value of y in this case. And a third and final test point, the value of x 220, the value of y 160. We see there clearly for every single point that we identified in the region, the value of x is greater than the value of y. And it might be a paradox or irony that the inequality is written this way, x is greater than y, yet still the region that we shade is below the line or less than the line. There should really be no discrepancy, and the reason for that we will see on the subsequent slide. Here we see that x is greater than y in every single case, and that justifies us shading this region. Now consider the same region that satisfies x is greater than y, for which the boundary line is y is equal to x. A test point is never irrelevant, but the region could have been more true to form if it were written with y on the left hand side. And why true to form? True to form because it is more appropriately written with the dependent variable on the left-hand side and the independent variable on the right. Not only that, but by so doing, we have x is greater than y. Therefore, y is less than x. That means the inequality sign is also true to form. It will be true to form because the independent variable is on the right and the dependent variable is on the left, which is appropriate. It is also true to form because now we have this less than sign, which will be true to form because the region will be actually less than the line that we have, less than or below this line. Because of the less than sign, we are seeking for the region that is less than or below the line, which is a direct interpretation of the inequality. We have the dependent variable on the left-hand side where it should be, and also the less than sign, which will give us a better interpretation of the inequality as it pertains to the actual inequality, which is less than, and also the shaded region, which is less than the line that we have there. Equations and inequalities are easy to interpret when the dependent variable is on the left-hand side. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.